So here we go. Power series, the goal is to determine the radius and interval of convergence of a power series. So here's the big definition. Let x be a variable, a real variable in this class, but in reality it doesn't have to be. And Cn, a sequence of constants, a series of the form. Okay, so this forms the sum, we start n at 0, sum n equals 0 to infinity, Cn x minus a to the n power is called a power series centered at a. And when a equals 0, which is often the case, this power series becomes the sum from n equals 0 to infinity, Cn x to the n. So that if you write it out longhand, you get like C1 x to the first power plus C2 x squared plus C3 x to the fourth plus C4 x to the fifth, and then plus dot dot dot. And you could write out the first version of it as well, except instead of x's, you have x minus a's. So notes. Number one, a power series can be viewed as a function of x. So in other words, I could set f of x equal to that power series that I defined above. And that's where the domain of f is the set of all x for which the power series converges. So in other words, we wouldn't try to plug in an x value if you get a series that doesn't converge to a number. Okay, number two, a power series always converges absolutely on an interval I centered at A. The radius of this interval is called R, where R can be 0 or infinity. And this statement can be proved. You can look at Appendix F in your book for the proof. But the ratio test that we apply will help you believe it, I think. So within the particular examples we look at, we'll address, what is this I thing and what do we really mean by R. Note number 3. We are friends, you guys. We are friends with a power series already. It's called the geometric series. So you're not used to writing it this way, but the sum n equals 0 to infinity of x to the n is a power series. Here's how you're used to writing it. You're used to starting n at 1, and you're used to there being a factor of a and then calling the common ratio r and then the exponent n minus 1, right? But the sum n equals 0 to infinity, x to the n is just a slightly different form. X then represents r. And instead of starting the series at 1, we start at 0. But then what happens to this exponent right here? We have to go up by 1. So instead of n minus 1, it becomes n. And so you replace a with 1 and r with x, and you get exactly that version of what we're calling a power series. So that's a power series we know. It is geometric with capital R. So that's the radius of convergence. It's not the same as this lowercase r. Capital R, what's the radius of convergence? Let's start with I, which would be the interval of convergence. On what interval does a geometric series converge on? Interval of convergence. So say that again, sorry. -1 to +1. So the interval of convergence would be -1 to +1. So think of the number line then. Think of this interval as a one-dimensional circle. So -1 here, 1 here, of course 0's in the middle. So the interval from -1 to 1, what's the radius of that interval? 1. The length of the interval is 2. That would be like the diameter of a if this were a one-dimensional circle, that'd be the diameter. The radius is 1. So the radius of convergence for this geometric series is 1. Okay? So in other words, as long as x is in between -1 and 1, that sum, that series, n equals 0 to infinity x to the n, converges. Any questions so far? Mostly just vocabulary so far.